Okay, we've already started this, and Jonathan was nice and said I should record this, so that's what I'm doing. Alright, so anyway, this is taken from, what is it, page 219, and it's number 27. Alright, and so you'll have a problem that'll look similar to this on the test. You'll have one problem that looks similar to this. This is the one where you have two parallel lines, you're trying to find the distance between them. First thing I did is they gave the equation like this. First thing I did is solve for y. So I solved for y, got this equation, I put it up here. Actually, I put it right here. That was the other equation they gave us. So these are the equations of these two red lines right here. So I graphed them both, and then what I have to do is find the distance between these two lines. So I take a point. I could have taken this point right here. Do you see that? And then made a perpendicular up here if I wanted to. I could have done that. Why did I pick this? Well, I just picked this because 2 is a little smaller. I just thought it might be a little easier with the 2. That's the only reason I picked this point. So I made it perpendicular to here, and I want to find the length of this perpendicular line. Before I do that, I've got to find the 2 points, okay, because we're finding the distance between these 2 points. So I know this point right here, which is 0, 2. I got to find this point. That's why I made it xy. So my process in doing this, since I'm trying to find this point, do you see the two lines that form that point of intersection right there? I've got this line, which I already know, which is y equals 1/4 x minus 15. That's why I wrote it down in red right here. And then I had to find, and we just finished doing this, I had to find the equation of this little blue line, this distance line. So I found the y-intercept first, and you just look at it. The y-intercept is positive 2. Then we found the slope. The slope of this line right here was positive 1/4. So the slope of a line that's perpendicular to it is going to be the negative reciprocal, which is negative 4. Does that make sense? Alright, so y equals negative 4x plus 2 is the equation of this line. So here are my two equations. Now, this is where we're at right now. Now, I've got these two equations of the lines that form this point right here. What in the world do I do to these equations, and why do I even need them? What do you think? Evan, what do you think? What do I do with these two equations? Okay, do some substitution. That's right. So basically, watch. They're both equal to y, aren't they? So if they're both equal to y, they're both equal to the same thing, then they're both equal to what? Each other. Good. All right, so they're equal to each other. So that's what I'm going to do. I'm going to set them equal to each other. So 1/4 x minus 15 equals negative 4x plus 2. And that's basically just substitution. I took this, I substituted it in for this y right here. Do you see that? Because they're both equal to y. And now, here's probably the hardest part of the whole problem. I don't think it's the hardest part of the problem, but I think for students it is, just because of the fractions. But use a calculator, for goodness sakes, if you can't do this. Watch. I'm going to add a 4x to both sides. I add a 4x to this side. We'll do that in a second. Then I take a 15, put it on the other side, take that 15, put it over there. So let's see what we get. We got 4 plus a fourth. Well, 4 1/4 is that, isn't it? If it's easier for you to do it that way, that's fine. Change that mixed number to an improper. What would that be? 17/4. Okay. You see that? Or what I would have thought of it this way. 4 is the same thing as 16/4, isn't it? Do you agree? 16 plus 1 is 17/4. Either way you do it, right? You get it. Make sense? So it's 17/4 what? X equals, that cancels out, equals 17. Look, they've rigged these real nice for you. You may not think they've rigged them for you, but they have. All right, because it just works out real pretty. So how do you get rid of 17/4? You multiply by the reciprocal, right? Done that. You've done that since the first time you ever learned how to divide fractions. Okay, you learn to always multiply by the reciprocal, and that's basically what we're doing here. So you multiply by 4/17 here, multiply by 4/17 here. Do you see what I mean where they rigged them? Because look what happens. The 17's cancel, so what is x? It's a nice pretty 4, isn't it? Okay, so that's what x is equal to. Now I got to solve for y. I could put that into here, or I could put it into here. Excuse me, it doesn't make any difference whatsoever. Let's just put it into the blue one. Actually, the red one's a little easier, I think, because 1/4 times 4, do you see that? It's just 1. 1 minus 15 is negative 14. But for some reason, I don't know, people just don't like putting them into where there's a fraction. But in this case, excuse me, something in my throat. So, I don't know, I just think it's easier that way. But let's do it this way. So y equals negative 4 times x plus 2. What do we get our x to be? 4. That's negative 16. Negative 16 plus 2. Oops. 2 is what? negative 14. Same thing as we would have gotten put it up here. So that's what y is equal to. Y is equal to negative 14. So why do we care what x is equal to and what y is equal to? All because of this. Because I want to find that point right there. I want to find 4, negative 14. That's what I'm trying to find. Why do I want to find that point? What's the big deal about finding that point? So I can find the what? The distance between those 2 points. All right? That was the work right there. That was the hardest part, I think, of the problem right there. Once you understood that part, the distance part should not be the problem. I wouldn't think. I would hope not. So what are our 2 points? Our 2 points are 0, 2, and 4, negative 14. And now we just put it into the distance formula, and that should be, hopefully, that should be pretty easy for you. All right? It's just plug and chug, right? So subtract the x's here. So 4 minus 0 is 4. And then subtract the y's. Negative 14 minus 2. What's negative 14 minus 2? It's negative 16. All right? You could make it negative or positive because you're going to square it anyway. It's going to be positive one way or the other. And let's keep going. This is going to be what? 16 plus, what's 16 squared? I think it's 256. Chandler, you got it, don't you? 16 squared. Do it real quick. I think it is. 256. Yep. And then add that to 16. So that's a 272. All right. Now look, I'd be fine if you just kept it like that. All right. If you look in the back of the book, they write it 4 square root of 17. It's because they took a 16 out of this, took the square root of 16. I don't care that you do it like this. When you get into Algebra 2, I'm going to make you simplify your radicals, but in geometry, I'm fine if you just keep it like that. I don't know. Since I've been here, it's always been me geometry, then Algebra 2, but this year they changed it, and I'm doing all geometry this year, so I don't know if they're going to change it back or not. All right, so there you go, and that's it. That's all you got to do. If you want to put that into a decimal, you can, but I don't see any reason to. Do you see any good reason to make that into a decimal? I don't see any reason. Just keep it like that. All right. It's just one more chance to make a mistake, isn't it? If you had to change that to a decimal, keep it like that, circle it, and you're done. All right. What do you think? Is it better now? Okay. Go back. I've done this probably 3 other times. I think at least 2 or 3 other times on the computer on YouTube. So go back and look at it for some other problems, and try some on your own. Right. Just try one. Work it out, and then put the YouTube video up on there and see what I do and see if it matches up with what you do. All right, we can do another one if you want. All right, one big part of the test is going to be equations of a line, and there'll be one problem, just one problem, that says to put it in point-slope form. But you got to know what the point-slope form is. That's the deal. Okay, I'm not going to give it to you. Remember what it is? Y minus y1 equals m times x minus x1. And this is useful if they give you a point and they give you a slope. Look at number 27 on page 225. All right, so it's page 225, number 27. And look what they give you. They give you a slope, or they give you a point for negative 9, and they give you a slope. Well, how much easier could this possibly be? Not much. All right, I couldn't imagine this being any easier. The only thing hard about this, what's that?
If the y was positive.
The y was positive? Oh, yeah. Look, that's what you have to know. All right? You know the point-slope form. They give you a point, they give you a slope. It couldn't be easier. But you got to know which one to put in for what. Remember, it's the ones with the 1 in front of it are the ones you're going to replace with a number. This y just stays y. So it's going to be y minus.
Plus 9.
Right, it's going to be minus and negative 9. What's minus and negative? It's plus. Everybody see that? Equals m. What's my m? It's 2. Parentheses, x minus x1. What's my x1? 4. Boom, I'm done. That's it. It says write it in point-slope form, so you keep it like that. Don't get the 9 on the other side. Don't distribute the 2. Keep it like that. All right? I'm trying to make it easy for you, aren't I? I mean, that's really simple. I just put it in point-slope form, and bang, I'm done. That's it. You got it? All right? Number 28 is the same kind of deal. They just have a fraction. That doesn't make it any more difficult. Look at number 29. This is number 29 from page 225. They say write an equation in slope-intercept form. Well, what's slope-intercept form? You got to memorize that as well. But this is one everybody remembers. Yep, it's y equals mx plus b. And what do they give you? They give you a slope. Oh my gosh. Number 29, they make it really easy. They give you a slope and they give you a y-intercept. It couldn't be easier. Alright, so the slope is 5 and the y-intercept is -3. So look, that's the slope, that's the y-intercept. You just plug those numbers in. There's really no math involved. It's just knowing what the formula is and plugging a number in where it's supposed to go. Alright, so y equals m, which is 5x, and then plus b, or plus a -3, which is the same as -3. And there it is, right there. There's got to be a harder one than that, right?
The next page.
Yeah, the next page, but let's do this one. Let's do 31. We'll kind of work our way up to it. So this is -3, 12, and 15, 0. And they are asking you, now remember I said, even on the test, they only give you one problem where they ask for point slope form. Everybody understand that? The rest of them is all slope-intercept form. So make sure that you understand that. So they ask you to write the equation in slope-intercept form given these 2 points right here. So what's slope-intercept form? Y equals mx plus b. So how do we put stuff into this? What numbers do we put into here? Well, you got to do a little work, right? First thing you got to do is find the slope. Everybody with me? So find the slope first, and you got to know how to find the slope. I think there's even a problem on the test where it says find the slope of a line given these 2 points. All right, that's a basic, a real basic thing that you have to be able to do. And how do we find the slope? What do? We subtract something. What do we subtract? Put it on top.
Y's.
The y's, because the change in y over the change in x. Rise over run. Rise goes up and down, right? The y-axis goes up and down, so we subtract the y's. So it's 12 minus 0. And then we subtract the x's, which is -3 minus 15. So this is 12 over what? -18. Do we keep it like that? No, we reduce it. What goes into both of these? 6 does. 6 goes into 12 twice, and it goes into 18 3 times. Negative out in front, that's my slope. You with me? So that's half of what we're trying to do. I'm going to circle it, but that's not my answer though, okay? Just so I can remember I'm going to use it. Now, I've got the slope. Now what do I have to do? Find the y-intercept. Now how do I do that? Well, let's plug all the stuff into this equation that I know, and let's solve for b. So we're going to plug what we know into y equals mx plus b. Pick either this point, oops, off my page here. Pick either this point or this point. It doesn't matter which one you use for the x and y. But I can't take the x from here and the y from here. Does that make sense? I can only use one of these points. Which point do you think would be the easiest one to use? Probably 15, 0, don't you think? Because the 0 probably makes things a little easier. So let's use this point right here. Alright? And when I say use it, what are we going to do? We're going to put the y in for the y. We're going to put the x in for the x. We already know the slope. We just found it. And then we can solve for b. So what is the y on this point right here? It's 0 equals m, which is -2/3, times x. What's x? 15. Put it over 1, and then plus b. And now I can solve for b. So 0 equals, let's see what happens here. 3 goes into the 3 once, 3 goes into 15. 5 times, what is that? -10. So add a 10 to both sides. What's b equal to? It's equal to 10. All right? There's the slope. There's the y-intercept. Put it all together. Y equals -2/3 x plus 10. And there it is. That is your answer right there. Okay? So if they give you 2 points, you should be able to find the equation of a line by doing that. Find the slope first, then take either one of these points, it doesn't matter which one, and put the x in, put the y in, solve for b, and then you've got your equation of a line. It's really not that hard. All right. Alright, this is on page 227, number 13. I got to go quick. We find the equation of a line, y equals mx plus b, of a line that goes through this point and is perpendicular to this line right here. Well, first of all, I got to find the slope. How do I find the slope? Do I just look here and take that slope? No, because my line is perpendicular. What's true about lines that are, the slopes of lines that are perpendicular? So the slope is not going to be 2. What's it going to be? -1/2. It was as easy as that, okay, to find the slope. Now I just got to find the y-intercept. What do? I take this point, take the x and y, throw it into here, and then I've got my answer. I got to stop now, sorry.